Okay, so today we're going to be talking about this. So please, if you have comments or questions, try and work as many ambiguous statements or puns in as possible. I think that'll really enhance the presentation. We're going to talk about this and end somewhere around ES6 classes, and we're going to work our way towards that. So some questions to consider through this presentation. What is this? What is prototypal inheritance? How does this relate to inheritance? What are classes in JavaScript? And how does this work with classes? Okay, this. So it's my belief that this is probably the most misunderstood keyword in JavaScript and a most frequent cause of problems. So when you search for Stack Overflow, this JavaScript, you get almost 1 million results. The top answer has 853 votes, but unfortunately has not accepted any answers. So here's a couple definitions that should simplify this. First definition, this equals the context of the nearest parent object from which this was evaluated at execution time. So like I said, simple, right? That was a joke. No need to laugh though. All right, a simpler one. In JavaScript, this refers to the object invoking the function that's being executed. So let's try out some examples. I'm going to have some code, and let's talk through it, and then let's try it out and see how that evaluates to see if that definition holds true. All right, so just in the global scope, if you log out this, what would that log?
The window.
Window? Let's try it out. How's the font size on this, by the way? Is that a little better? Console log this. Too big for the console, so I need to yeah, it's the window object. There it is down there. There's our window. So does that definition hold, or why or why not would that hold? Why would this refer to the window? I said it was the nearest parent object from which it was executed. That's because right now we're in this global namespace. And if we check what type window is, you said it's an object. Window is an object. So when we're evaluating code like this in a global namespace, we're evaluating it within the context of the window object. Okay. So here's another one. If we have a function foo, and in that function we log this, and then we call foo, what would this equal inside that function?
Is it inside any other object?
Just that, just the code that's visible. Window as well. I think we're right, it is window. Right. So why is that the case? It's because when we create a function like that, this function by default is going to be assigned onto the window object. So if we open up our console here, say function foo, like that. There's foo. We can also say window.foo. Right, those two things are equal. So when we declare a variable or a function in a global scope, it's the equivalent. We're equivalently saying window.foo is this new function.
If you're doing that in Node.
If you're doing that in Node, so it wouldn't be window, but it would be the global scope of Node, which is I think that's the process variable.
I'll try it.
So we could try that actually just as an experiment. There's foo. There's this. This is.
Will you type out this?
Yep. There you go. So it's the same in Node as well. So there's a parent object, which we're executing everything in anonymously.
It's called global.
Global.
Commonly called the global scope.
Yeah, the global scope. Yep. So the global scope in Node is called global. The global scope in a browser is called window. All right, here's another one. So an object foo which contains a function bar, and if we execute that, what would that be? What would that log? It would log foo. Why is that?
Foo is the object which makes the function fine.
Yep. There's our foo object. Okay. Let's get a little trickier here. So if we have a function called clickHandler, and we're logging this inside a clickHandler, and then we're invoking that clickHandler on an event listener of a DOM element, what would this equal inside this context?
DOM window.
So somebody said window, somebody said the DOM element. Whoever said window, why do you think that? Or
You're
what?
defining the function inside the window object.
Okay. And you said the DOM element. Why do you say that?
Because it's being invoked on the DOM element.
Because it's being invoked on the DOM element. That's right. So it's going to be the DOM element. So if we try this out, let's say, so if we do type of document, is an object. And then if we do, not only is the document an object, but the query selector that we query, that's going to be an object as well. So if we do document.query selector, let's see if there's any anchor tags here. Yep. So that's an object as well. So because this function is being executed on its nearest parent that's invoking this function is an object. This is the object it's going to refer to, is that DOM node. Okay. And so this, if you need to get data from the DOM node, and your code is structured like that, then you can use this to refer to the DOM node that you attached the event listener to. So a common workaround if you need to get access to the global scope in the case where you have some sort of event handler is to declare a that variable or a me variable or a self variable or something like that. Who's done this? I have. What's that?
Window.
Yeah, you could do window unless you needed to refer to something else, right? So here's something I think is a little better to do. Rather than declare a that or a me variable, we can use the bind function, and bind attaches any context you want to this. So you can pass in a this for the inside of that function to have. And so if you want the click handler to have access to whatever its scope is when it's defined at that moment, then you could say click handler equals click handler dot bind this.
Hey Mike?
Yeah.
You still have that in the console log though. Did you do that?
Yeah, that should say this. The copy paste error right there. Thanks for pointing that out.
If you still need access to the DOM, like for example, now this is no longer equal to the DOM element,
Mhm.
the event, you normally do event target or
That's right.
target to still get the DOM element if you need access.
Yep.
to it.
Hey Mike?
Yep.
In your previous slide, you still referenced that.
Yes. Thank you. Someone else actually just made that comment, but didn't speak loudly enough for that comment to propagate all the way to the back corner, I think. So Jeff, speak up next time.
Okay.
I actually couldn't even hear you say okay. I just heard Jared say you said okay.
Well, he's my repeater.
All right.
He said I'm cool.
Propagating the event.
Yeah, propagating the event. All right. So here's one. If we have a variable which is an object called person that has a greet function inside of it that logs this, and then we assign that function to another function and call it, like myGreet. We'd pluck it out of that object and execute it. What would this equal in this context? Person?
Window.
So those who said person, why do you think that? I think the nearest parent. Jared, you said window. Why do you say that?
It's the nearest parent object at execution time.
The nearest parent object at execution time. So let's test it. Yep, it's a window. When it says it's too big, that means it's the window. You can open up the actual Chrome console here. Holy smokes.
It's a little small.
There you go. So repeat that. Why is it window and not person?
It evaluates the closest object when it's executed.
When it's
Not
executed.
when you write it. That's why it's very different than other languages where this is static. This depends on how it's called, how it's executed.
Exactly. So because we've taken this function and we've kind of plucked it out of that person, we're executing it in the global scope, right? So this now equals the window, which is the same, the cause for this, why this works, right? Because you have this click handler. This click handler is also defined in the global scope, but we're executing it now in the context of a DOM node. Okay. Here's one. This is the inverse of that problem. So a function declared in the global scope, Baz, that logs this, but then we're calling that function within a function in an object. So what do you think? What's that going to log? Foo? Do you think it'll log foo? Any other thoughts?
They're all free. They're all afraid to answer.
Okay, so if you said foo, somebody said, I didn't hear who said foo. Did Blake? Did you say that? Why do you think it'll be foo?
Because it's both inside of food.
Okay. Who? Any dissenting opinions?
I'll go with window.
You're gonna go with window. Why is that?
This function is bound to window when it starts.
Because this function is bound to the window when it starts. Okay, should we try it out? Let's see. Window. Let's look close. Look closely, okay? So, oh, it's too tall. Anybody got a yardstick? All right. So foo.bar is a function, but bar isn't logging anything. Baz is our logger. Baz is not attached to an object. It's just being. It's not. This isn't being passed in by bind, and Baz is not owned by an object, right? So Baz is still being executed, and it's executing that function.
So if
Jared.
you
Could you,
go ahead.
so could you define another element and assign its value to Baz, and then that would log it?
Yeah. Should we try it? So if we assign another element, so if we just say bar equals Baz, like this, and then log it, then it equals the object. This.
Takeaways, don't use this.
It's intuitive. I mean, what I'm trying to demonstrate is that this basically is intuitive and works the same in any context.
Yeah, we got that.
Got that?
I
Okay.
think everybody's on the same page.
So here's a twist. Everything we've demonstrated so far uses the ES5 and below function declaration. with using the function keyword, right? If we use an arrow function, one of the key differences of arrow functions, also called lambda functions, is that they don't create its own context, or they don't inherit from its parent context. So if you use an arrow function, the this inside the arrow function is not going to be that object. It's going to be the one above it. So in this case, if you use this as an arrow function, that would refer to the window if that said this instead of that. Go ahead.
Clear?
Said like Babel,
Yeah.
arrow function, is that just doing a dot bind on the function that what's transpiling to? Bind this.
You can see how it transpiles. Sure. So I don't think arrow functions don't really need to be transpiled anymore. I think most browsers support them. But if we try it out for those that do, so that's how that function looks like. So if we just say turn this, oh, undefined.
Wrap it in an object. And then the actual function.
It's intuitive. All right.
That's exactly what I thought.
I'm actually a little confused why it's doing that. All right. Okay.
There is no bit.
So there you go, Babel. Okay, so that's this. So I think the simple definitions at the beginning, that this refers to the nearest parent object when the function was executed. I think that definition holds. I think those examples try to show that in some simple and some complex cases. That this always refers to the object that is the nearest parent of that when it's being called or executed. Okay, so more light subjects, prototypal inheritance. Okay, so what is prototypal inheritance? I think that's we know that JavaScript has prototypes and that we have prototypal inheritance. What actually does it do? So let's compare and contrast classical inheritance versus prototypal inheritance. So classical inheritance, classes define patterns, which are not actual things, right? They're templates that you can use to instantiate objects. You can have like static members of classes that you could call, right? But classes themselves, we think of as templates or like blueprints for the creation of an object. So in JavaScript in prototypal inheritance, there's really no such thing as classes, only actual objects. So everything that you can type in your Chrome window, so you type in object, type in window, type in math dot, whatever, right? Those are actual objects, not ideas or blueprints for objects. So there are different types of inheritance, right? Multi-inheritance, single-level inheritance, multi-level inheritance, multiple inheritance going like this way from two different types of things, or hybrid where you're going two ways and another parent that way. So in prototypal inheritance, parent or children only inherit from their prototype object, which is their parent that they're inheriting from. So a common thing is that they're both systems for sharing and reusing functionality and behavior. So how does it actually work? So again, in JavaScript, in prototypal systems, there's no such thing as classes. We have a class keyword, which we'll talk about later. But our traditional idea of classes does not exist. There are different objects, which are global objects in every JavaScript environment. Object, function, Boolean, symbol, error. There are several more. right? These are actual objects as defined. So function in your JavaScript engine, somewhere it says function is an object that has these properties. And then when we invoke the function keyword, it's calling a method on that object, right? Object is an actual object. There's an object. So these are fundamental basic objects on which all other objects are based. This includes objects that represent general objects, functions, and errors. So we'll take object for example because that's the one that most of everything is based on is object. So object has methods which are static methods like object.freeze, object.keys, object.create, but it also has prototypal methods that other things inherit from. So if you have an object that's not the object, it's your user object, that user object is going to have access to these methods, like toString or value of, because it's inheriting those methods from its prototype. So what does the prototype actually look like? Every object contains a prototype property, which is a link or a pointer to the actual object that it inherits from. When a method which is not defined on an object is called, the prototype chain is crawled, or it just cycles through the prototype chain until it finds somewhere that one of its parents have that method or have that property, or it doesn't have it, and then it returns, this method is not defined on this object. So here's an example, person. If we call person.toString, it will print out object, because toString is on object is kind of not well defined, not very usable. But we have a person object which has a name and a prototype property, and that has a proto, which is a link that links to the object, which has things like object.keys as a static method, and then somewhere down the line it has a prototype which contains properties, and it finds toString. So when toString is called, it probably uses this inside toString, and because toString is being now evaluated on the person, the this inside toString is talking about the person object. So here's another example with a deeper chain. If you have a cat with a name and a prototype, and you want to toString that cat, right? That may point to an animal as its prototype, and it's going to say, do you have a toString? Do you have a toString? Nope. Okay, let's check your prototype, and then it'll go to the object until toString is found. So you can override prototypal methods. It's not very it's kind of an anti-pattern to place prototypes on the default objects or the global objects. But if you have these custom objects like an animal object that you want to provide some smarts to, you could provide a toString function on an animal object that would be found, and then it would never have to look back to the object. There's a word that means when you say a word so many times it starts to lose meaning and it sounds weird coming out of your own mouth. Object. Fun. All right. So how does this relate to prototypal inheritance? So if you have a function, let's say that function accepts some parameters, you can take name and age, then it can assign those parameters to a this. And if this is all we had is this thing right here, in this case this would equal, what would that would equal the window, right? But if we call that function with the new keyword is passing a new context or a new object into the this of that function. And so now inside this person function, this refers to a new blank state object. So what that's going to return is just an object that has these properties and then has a greet function on it. So this is called a constructor function. So if you're using new with a function, we're constructing objects. And so this is a constructor, right? Constructor function. Yeah, go ahead. Can you speak up a little bit? Sorry.
With classical inheritance, we haven't done really comparison, but you can't go back up and modify the parent.
Mm-mm. Yep. You could add properties to the child, right? But you couldn't modify the parent.
I think it's like just worth making sure it's very, very clear that every step along the way in the inheritance chain is a live object that can be modified.
Yes. Yep. I'll repeat that for everybody in the back. So every step, Jared said, every step along the prototype chain, the inheritance chain, is an actual live object. Because there's no classes. There are no abstract things. Right? So this person is going to inherit from object when it's returned, right? And you can modify object itself. Although I'd say that's probably not wise to modify object. So we can add prototypes to that function. So this function, instead of having do work or greet declared inline, this would make greet be now on every single object has its own greet function. You can add functions or add methods or properties to the prototype of that constructor, meaning it's going to now look at that inheritance chain and find the prototypal function, so it's only going to be defined in that one place. So with this person, if we instantiate a new person, Bob, from our constructor function, and we call bob.doWork, it's going to look at what it inherits from and find that doWork function on the prototype.
Object is it a property or a function called keys?
Object has a static method called keys.
So can you call bob.keys?
No. You
So
could call
describe that node.
you can call object.keys of Bob.
Okay, and I understand. Right, but why can't I call bob.keys?
Because prototypal function, the prototype, are things that objects will inherit. There are static methods on the object. So object mdn.
So you could do bob.toString, but not object.
Exactly. Yep. So here these are static functions on an object, which means when you use them, you actually typed object.assign, object.create.
How would you create a static function?
So if you created a static function,
First example was
yeah.
If you remove prototype from that second one.
So you can remove prototype from this one, or this greet example is a static. Would be a static method on it.
for every instance of person, there is a greet function.
Yes.
Could you also create it with the keyword static?
The keyword static.
In the newer syntax, but not.
Yeah, I'm not familiar with that. But I think that's a Is that an ES7 proposal?
It's in six.
Oh, is it in 6?
In
Okay.
classes.
But you have to use the class.
If you're using class syntax, yeah.
Technically, actually, the way you have your pointer working there is actually incorrect.
Okay.
Underscore proto. It does not point to the constructor.
Sure, it would just point to
It
objects.
actually
That's right.
points to the prototype value of so like bob.prototype.__proto__ actually points to person.prototype,
Not person. Oh, so that.
person is what you would normally consider in classical inheritance for the whole static thing. Person is what you would consider to be your class definition,
Yeah.
or your type if you were using C# or Java. That's your type right there. And if you wanted to create something that's quote unquote static, then you would just add a property to person and not to your prototype. So this .name up there that you see within the constructor, those are instance members, not static members. If you wanted a static member, then you'd have to say person.name equals ...
Sure.
Because when new is called, what's actually happening is it takes pretty much essentially a clone in a way of person.prototype and sets the prototype of Bob to, it's not actually a pointer to prototype, to person.prototype, but it takes pretty much all of the, like, do work, you see do work right there.
Mm-hmm.
Pretty much takes a pointer to that or a reference to that, puts it under bob.prototype. So, and so, I mean, if you really want to have the concept of static and instance variables, you just need to keep in mind that instance variables, you either set them or declare them within your constructor or within another function of the type, or it's attached to the prototype itself, not. It's just, it's weird because the constructor is the type, whereas in other places, the constructor is its own function, not the type. But in this,
Thank you.
You can repeat that?
I'm not going to repeat that for the class.
But you can get the constructor from the prototype.
Yeah.
That's nice.
All right. So ES6 classes have been mentioned a few times. All right. So I'm going to have like 5 slides that basically say the same thing, just to hammer home the same point. So managing inheritance over multiple objects and prototype chains is complex and difficult, or can be complex and difficult. So ES6 classes make creating objects with prototypal inheritance easier. ES6 classes are syntactic sugar to make constructor functions look more approachable. So I'm going to repeat that. ES6 classes are syntactic sugar to make constructor functions look more approachable. So if you have any wild ideas about the class syntax making JavaScript classical object-oriented programming, you get those ideas out of your head right now. It's prototypal for life. All right, so this is in the MDN docs. This is how it says it. JavaScript classes introduced in ECMAScript 2015 are syntactical sugar over JavaScript's existing prototype-based inheritance. The class syntax is not introducing a new object-oriented inheritance model to JavaScript. JavaScript classes provide a much simpler and cleaner syntax to create objects and deal with inheritance. So ES6 classes are not classical object-oriented classes. I think that's the 5th of 5 slides that say the same thing over and over again. To repeat, just to hammer home that point. So if we have so here's what this syntax looks like. If you have a constructor function and you're creating a constructor, or you're creating an object like this, this is the equivalent example of that using a class syntax. Class person, it has a constructor method which takes in properties and then assigns those properties to this. And notice we're calling that class when we're instantiating an object with that class. We're calling that class with a new keyword. So parts of the class syntax, there's the class keyword. It just has opening and closing curly braces. That's new for some people who haven't seen the class syntax in JavaScript before. It's not a function, so you don't have parentheses and then curly braces. It's just the name of the class followed by curly braces. It can have a constructor method, and it must use the new keyword. If you don't use the new keyword, then it will error. It forces you to use the new keyword. So this is like a constructor where if you don't new up your object, then your code will not execute. Jared?
I think it's a valid point to make that what you're passing in to that new constructor, right?
Mm-hmm.
Right now, you're getting almost exactly the same thing back.
Yeah.
Right? So
you're just getting back this object, basically.
So pretty much classes in most contexts are overkill.
Yeah.
Right? Like it's easy to create objects in JavaScript.
Mm-hmm. Yeah, classes could be thought of as object builders, right? Because that's what they are. They're syntactic sugar over top of constructor functions. So if we paste this in here, and now let's log Bob. Bob is this object, right? Let's see. I'm gonna paste this in the window, and then we can see what this looks like in the window, or in like a native execution environment. Oh, didn't show a function. Let's see. So this is if you're using Babel, because I think many browsers support classes, but if they don't and you're using Babel, this is what this evaluates to. This is what that compiles down to. And look, it is a constructor function. It's a function called person, and I have this class call check. What that's going to do is ensure that you're calling it with the new operator. It's going to do some check, and then if it's not called with the new operator, make sure it is. Yeah.
I assume this is correct, but whenever you're doing a new class or doing an instantiation, is it best practice to say, hey, if name's not here, let's send it as undefined, or not undefined, but empty string? I know with the new ES6, you can actually set that. Is that the better practice to be doing?
If you want to have defaults, yeah, I'd say in many cases you do want to have defaults, and in many cases you don't. So, up to the developer to determine the business needs of that function.
Go back to your code then, okay. And just now do a console.log of the thing that you piped in to new person. Just the actual literal there.
You want me to log this object directly?
Yeah.
I'm not sure where you're going with that. Just to show that it's precisely the same.
Yeah. So
Yeah.
You could have just said Bob equals that.
exactly.
Yeah. Yep.
The point being is you probably don't need classes.
Well, so what you did get out of that is
Well,
you're going to have a name and an age, even if you don't give it one.
Yeah.
But it's going to have an undefined value, is that right? If you didn't pass it.
or you could use a default value. Yep.
So
And
you're
there are other things.
enforcing that's at the new, and you're enforcing that these attributes are there.
Yeah. Also, so classes make prototypal inheritance easier. If you need to do prototypal inheritance, then classes are an easier way to do it. If you're not using prototypal inheritance, then in this toy example, then yeah, it doesn't do much.
But inheritance is almost always bad.
Yeah, I think
In
favoring.
I mean, we can think of the one-offs where we use it, like extends React component, we use
Yeah.
it. But there is very, very few times that you want to use inheritance in JavaScript.
Sure.
That's
I think
just-
composition is usually a more powerful
Agreed.
design pattern than inheritance. But this is part of the language, and this is what we're talking about.
Question. In that on classes?
Yep.
I know in TypeScript I see it a lot, but can you actually, with these new classes, can you do extends?
Yes.
Thanks.
Extra donut. So classes can use the extends keyword to create a prototypal inheritance link. So this is the actual inheritance part, right? This is not inheriting anything. This is just an object maker. So classes can use extends keyword to create prototypal inheritance links. If you have an animal class and a cat class, cat can extend animal. And in its constructor, pass the thing it extends, its parent, or its super class, can pass those the properties that it needs. So in this case, if you have a cat, and there's an animal, animal is an object. So that would be the prototypal inheritance chain for cat objects, which are really just objects that are in the shape of a cat, as we've defined from our object maker.
So if you put that into the Babel, what would it be big object?
So there are two things. There are two constructor functions. And then they have this helper called inherits.
Should we look at that? Is it just using object.create?
Yep, so it's using object.create.
Which is another way to do inheritance, yeah.
Mm-hmm.
What did I say?
So, in addition to being object creators, they can also be object creators which contain method object creators. So we could have a method. In reality, a method is just a function that's attached to that object. Right? So if you have a speak function or a speak method on this object, then you could execute speak and it would return that string. Yes, emoji are valid characters now in strings and parts of JavaScript. So first person to name their variables emojis, I think, also extra donut. So here's an example. So in our method, let's use this. So this dot name, if we pass a name Spot, this cat's name is Spot. This dot name, because this is now name, we're passing on to its parent. This dot name is resolved by following the proto chain up to animal. So we're not saving the name here. We're passing the name to its superclass, the thing it inherits from. So when we evaluate this dot name in that return statement, it's going to follow the prototype chain until it finds a name. Yeah.
So for each cat object that you create, is it also creating a separate animal object?
I don't know the answer to that question.
Shared prototype.
Yeah, shared prototype. Well, if you're passing, yeah, that's right, because these are now going to be, because it's going to inherit that name.
So then is the name stored?
I think the name is going to be in cat. Good question.
That's why if you add something to the animal.prototype, then it goes to all.
Yeah, all animals.
Right, even if you add it after you create the cat.
Mm-hmm.
So is type of Spot going to be cat, animal, or
Object.
object? Does it always go to the lowest level?
Yeah, so type of is going to return the, so there's those global objects, like function, Boolean, object, undefined, right? So it's gonna go to those. It's gonna tell you what global object is this a child of at the lowest level. Did you have a question, Aaron?
I think it might be the same. I was just going to ask if you could also about this and speak of the cat would be animal.
If you logged out speak, like the called version of it.
Inside of speak.
Oh, what would you log out in that example?
This.
If you logged out this
This inside of speak.
inside of speak, it would be cat, because cat would be, you'd be saying cat.speak, or rather you'd say spot.speak.
But it's also, I think that when they ask what type it would log out, why would it log out cat? There's no such thing as a cat type in JavaScript.
Yeah.
Class doesn't create a type of anything. This isn't Java or C#.
Mm-hmm.
It's still just an object, as Jared was saying earlier.
Yep.
So also this would, if you log that out, would also depend on how you call it.
Sure.
So if you passed it by reference, how it's executed, right?
Yeah.
These follow the same rules that very first part of your slide.
So his question was, if you said spot.speak, that would log out spot as this.
Yeah, that was how it's executed.
Yeah.
But just even the class syntax doesn't guarantee this is staying to the class. It's just the point.
Sure. Sure. But as he asked his question, the answer was correct. Okay. Yeah, go ahead.
I just want to point out, if you're really trying to find the equivalent of type that you have in Java or C#, what you're looking for is spot.prototype.constructor.
Yeah, I think actually the easiest way to change JavaScript into a language like Java would just be to remove the string script from the end and just use Java.
Yeah.
So,
But
all right. So sorry, we got to move on for time. Sorry. So here's a bug in this statement. So this is going to be an exercise of find the bug. So a constructor which takes a value, a click handler, and then a render function which creates a DOM node, assigns that click handler to some event, and then returns that button. So where could a bug in this occur?
I believe it's in the constructor.
In the constructor? Why do you say that?
Because this dot alert value, what's the this in the constructor? Point two, is that the
Generated object.
The object, yeah. So this is the bug is not in the constructor.
This dot click handler is being assigned to the document element, not to the button object, right?
Well, yeah, we're assigning it to button, which is going to be the button element. But I think you're on the right track.
This is going to refer to the button.
Exactly. Exactly. When this click handler is called, this goes back to that, I think, slide maybe in the first 10 minutes, right? When click handler is called, what's going to be its nearest parent? No, the button. The button doesn't contain an alert value, right? Because of the way that this is evaluated. So yeah, and we talked about a way to solve that would be to use bind. So you could say in the constructor, click handler equals the click handler dot bind this. So you're saying whenever this dot click handler is called ever, always use the context of this, which is the object that's returned from that class.
We should also use that with an ES6 arrow function.
You can sort of, and I'll talk about that in another slide. But it does resolve that problem. All right. So in the last 5 minutes, let's apply some of this knowledge to React. So if you have a React component, there are different types of React components: functional, which are just pure functions, and then class-based React components. This is one type of React components. Let's apply what we've learned here. So a class. So this is just an object creator. So from that we can infer that whatever's returned from this is just going to be a plain pure JavaScript object. It's going to inherit some properties from the React.component prototype. So there's a constructor, and we're passing any properties in. We're going to pass it to that React constructor, React.component constructor. If we use the bind method from before, from that spot the bug activity, this click handler now will be properly referenced. This having this equal the object that this class returns, not a button itself. And we can use it like that. So here's an even easier way to do that, which Josh mentioned. So we can use the ES6 arrow functions as methods of classes. And this is an ES7 feature, which is very likely to be adopted. But likely doesn't mean 100%, it just means likely. So you're not going to be able to use this feature in a place like CodePen or JS Fiddle, but we have turned on the Babel option to have this work in the React Starter Kit. And so if you're using the React Starter Kit from the stack offering that we have, then you can use methods like that use arrow functions. So this is great, prototypal inheritance is great, React is great, the end. Thanks. Happy to answer any questions. Yeah, Chris.
So recently I was asked to encapsulate JavaScript, and I was
To what?
to encapsulate.
Okay.
And I read up on it. You're supposed to create an anonymous function and then call itself with this.
Sure.
I didn't fully understand that, and it might take too much time.
So create like a module that's totally encapsulated.
Well, they just want basically an object like, I didn't fully understand the question, but
Okay.
they said demonstrate encapsulation in JavaScript.
I see.
So looked up Stack Overflow, what I understood, you create an anonymous function,
Mm-hmm.
and then you call it immediately.
Yeah. So that pattern would be sometimes called an iffy or an immediate it's an anonymous function that's executed immediately. So a pattern like that look like, so a function like this, right? So var a equals 1, something like that. But then you could call this function immediately, doing something like that.
Is that because that function is being called on itself and it limits the scope to itself?
Yeah, so whatever you pass in there is going to be what comes into the method signature, the properties that are passed in. Anyway, yeah, this would be like an encapsulation of a module, which does allow you to create variables and have a scope that's executed, and then that function can be returned. Like you could return that object, but then any of that interior stuff would be just immediately destroyed after it's executed, unless anything is returned from it, like a closure. So I don't know if I can answer your question any better without understanding the question better. Okay. All right, thanks. Yeah, any other questions? Free to go, but stick around for questions. Grab a donut on your way out.